Hi everyone. Today we'll be discussing the LeetCode problem of the day, smallest missing non-negative integer after operations. In this problem, you are given a zero-based index integer array nums and an integer value. In one operation, you can either add or subtract this value from any element in the number. So for example, if you have numbers 1 to 3 and the value is 2, so if you pick this number and you can decrease 2 to make it -1, 2 and 3. So you can also choose to increase it. So then it will become 3, 2 and 3. So it says that the max minimum excluded of an array is the smallest missing non-negative integer in it. So suppose if you have an array and the max of this array is 0, because in this array the smallest non-negative number that is missing is 0. And the max of this array will be 2 because if you see 0 is present, 1 is present, 2 is missing. So 2 is the smallest non-negative integer that is missing from this array. So this is the definition of MEX. And you just have to return the maximum max of numbers after applying the operations any number of times. So if we just look at an example, we have the first example as 1 minus 10, 7, 13, 6 and 8. And the value is 5. So in first operation, he chose this number to make add 5 two times. So it will be 0. And in next step, he chose this number and decreased. Okay, not this. He chose this number and decreased 5 from it. So this will become 2. And next step, he picked this number and decreased 5 from this number 2 times. So this will be 3. And from this number, there's no changes. It remains 1. And this also no changes. And this also no changes. Because even if we try to decrease this by 5, we will again reach 1. So 1 is already present. So no need to decrease this. And same with 8. Even if you decrease 8 by 5, it will become 3 only. And it's already present. So you don't do it. So this is the array formed after the operations. So in this array, the max is calculated as the smallest non-negative number that is not present. So 0 is present, 1 is present, 2 is present, 3 is present, but 4 is not present. So the answer of this array will be 4. And this is the maximum max we can form. The output is 4. Now if we quickly look at the second input, we have 1, 10, 7, 13 and 6, 8. And here we have the value as 7. So in first operation, we can reduce this 7 to 0. And this one can remain same. This 10 we can subtract 7 and this will be 3. So this 13, if we subtract 7, it will be 6. And this 6, we can just keep it same. And from this 8, even if we try to subtract 7, it will still reach 1. So we don't need to do it. So this is the final array we can form. And in this, the max will be 2. Because 0 is present, 1 is present, and 2 is missing. So 2 is the first non-negative integer that is missing from this array. So for this output, for this example, the answer is 2. Now let's go over the approach. So by definition of max, it is the smallest non-negative number that is not present in the array. So suppose we have the array like this. 4 and 5 is missing. We have 6 and 7. So in this array, the max will be 2 because 2 is the smallest non-negative integer that is missing. Since we are trying to maximize this max value, so we want to transform this array such that all the smallest values are filled, and we want to have all the unique values, because in the mex, even if we have duplicate values, this won't help us in the mex in any way. So we can also avoid duplicates, and our main goal is to form the smallest numbers first, so that when we calculate the mex, it will be maximized. So if we take the same example again, Gen 7, 13, 6, 8. And also, we don't have any use for the negative numbers. So we'll try to convert the negative numbers into positive as well by just adding it. So this one will remain same. This minus 10, you'll add 5 two times. It will be 0. So this 7 can be reduced to 2 by subtracting 5. 13, 3 by subtracting 5 two times. So this 6, you don't need to subtract it, because when you subtract 5, it will become 1. So it's a duplicate. So duplicate won't help us in mex. So we keep it same. And same with 8. 8 minus 5 will be 3. So we won't do it. So we transform this array into the minimum possible numbers, and that is also distinct. So from these numbers, we just need to check what is the first non-negative integer that's missing, and we can see that 4 is missing in this array. So the answer is 4. So our goal is to transform any array into smallest distinct numbers possible, and then we'll try to find the max. So let me take an example so it will be a bit more clear. We draw it. Yeah. So from this array, we can form 0 by adding 4 a 4 to this. Also the value is 4 for this input. So we can form 0 by adding a 4 to this, and we can form 1 by subtracting 4 two times from this 9. We can form 2 by taking the number as it is. We can form 3 by subtracting 4 from here. We can form 4 by subtracting 4 three times from this. 5 can be formed by just taking this number. 6 from this. 7, take it as it is. And 8 can be formed by subtracting 4 three times from this. 9, you can't form 9 with the remaining numbers. So let's see. You can form 10 by just taking this number as it is. You can form 11 by taking this number as it is. And this number minus 6, if you add a 4, it will become minus 2. If you add a 4 again, it will become 2. Then again plus 2, it will become 6. So 6 is already present. Again add a plus 4, it will become 10. 10 is already present. So again add a plus 4. So it will become 14. So you have 11. And then 12 is missing, 13 is missing, and you have 14. So this array, we can transform it this way, such that all the numbers are as least as possible and no numbers are repeating. So once this is formed, you can just check what is the first number that is missing. That will be your answer. So in this case, our answer is 9. So now the only question remains is, how do we calculate this, and how do we know the first missing number from this? So for that, what we can do is, let me just erase this. So since we have the value as 4, and any number, suppose we have a number 20, it's really huge. So we can reduce it, we can decrease it by subtracting 4. And any number which is negative, like minus 6, we can increase it by adding a 4. So at any point, you can either decrease or increase a number. So let's pick this 5. So this 5 can be modified into any of these numbers. So 5 plus 4 will be 9, 9 plus 4 13, and so on. And also it can be decreased. 5 minus 4 is 1, and again minus 4 is minus 3, and so on. So we don't care about negative numbers. So any number can be modified into any of these numbers. So what we try to do is we try to take mod of all these numbers with 4, so that all these numbers lie in the range 0 to the value minus 1. So that means if I take the mod of all these numbers with 4, let me erase this. Yeah. So if we take mod of 4 with minus 4, we get 0. So here also we get 0, 0. Here 1, 1, and 2. Here you get the mod as minus 2. But then for minus 2, you can again just add this 4 to make it positive. So it becomes 2. This remains 2. We have this also 2. And this 3. E and 3. So by taking the mod, we have reduced the number array, which can be in the range minus 10 power 9 to 10 power 9 to the range 0 to value minus 1. Because whenever you take mod with a number, the remainder will be from 0 to the value minus 1. So here you can see all the numbers lie from 0 to 3. So once you have this, let me just write it as a frequency table. So we have 0, 1, 2, and 3. So 0 is present 3 times, 1 is present 2 times, 2 is present 4 times, and 3 is present 3 times. So this is the frequency array of the reminders when you take mod with 4. So using this, using just the frequency, you can find what is the first missing number. So let's see how we can do that. If we just move it up. Okay. So we have 0 3 times. So using the 0 once, you can form a 0. You have 0 3 times, right? So the first 0 can be used to form 0. So the second 0 can be used to form 4, because we don't want duplicate numbers. The third 0 can be used to form 8. And since we only have 3 zeros, so these are all the unique smallest numbers we can form. Now coming to the 1, we have 2 ones. So with the first one, we can form 1. With the second one, we can form 1 plus 4, which is 5. Now with 2, you can form 2. With the first 2. With the second 2, you can form 6. With the third 2, you can form 10. With the fourth 2, you can form 14. And 3 is present 3 times. So with the first 3, you can form 3. With the second 3, you can form 7. And with the last 3, you can form 11. So these are all the unique numbers we can form. So from this table, we can see that the numbers are in increasing order. So 0, 1, 2, 3, then 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14, 12, 13, 14, 15. From this table, we can see that 8 is missing. And sorry, 9 is missing. And we can say 9 is missing by looking at the frequency. Because here we have frequency 3. So that means this number can be used to form 3 levels. And this has frequency 2. So this can be used to only form 2 levels of the numbers. And this has frequency 4. So it can be used to form 4 levels of the number. And this has frequency 3. So it can be used to form 3 levels of the number. So just by looking at the frequency array, if we see the minimum frequency, so that will be our answer. So here the minimum frequency is 1. So that means you can form 1 with the first one. You can form 1 plus 4, 5 with the second one. And you can't form the third one. The third one is missing. So that means 9 is missing. And 9 is our answer. So if we just want to write it as a formula, we have the number as 1 and the frequency as 2. So the missing number, we can get the missing number by doing 1 plus the frequency, which is 2, into value is 4. So here we have 1 plus 2 into 4, which is 9. So by looking at this array, first you find the minimum frequency, and also you find the corresponding number that is leading to the minimum frequency, and you just do the number plus the frequency into value, and this will give you the minimum value, minimum non-negative integer that is missing from this array. Now let's quickly code the approach. So first I'm just creating a frequency array, and its size will be value, because it will store the numbers from 0 to value minus 1. So now let's iterate on the numbers. So we can have frequency of number mod value LUE plus plus. And since we can also, this will also lead us to a negative number. Suppose if we take minus 10 mod 4, this will give us minus 2. So to make this positive, all you need to add is for this 2, you'll just add the mod value. So this will make it positive. So it will become 2. So since the number can be negative, to make it positive, you'll just add a k, and then again you will take it mod, because it will again affect positive numbers. So suppose if my number is 6, and if I take mod with 4, it will become 2. So for the 2, if I add 4, it will again become 6. So to reduce this, we'll again take mod with value. Or to just keep it simple, let's just take like this: mod equal to nums percentage value, and if this mod is less than 0, mod plus equal to value. So this is the short form. So we can also use this just to be a bit more clear. So frequency of mod plus plus. So by doing this, we are calculating the frequency of all these numbers. And like we discussed, let me just write it again. So we have 0, 1, 2, 3. I think 0's frequency was 3. This frequency was 2. This is 4. This is 3. So this is the frequency array we have formed. So from this, we just need to find what is the minimum frequency and what is the number that is corresponding to it. So let me just take min frequency value and initialize it as digital.max value. Also int min number equal to, let's say first it's minus 1. Let's just iterate on the frequency array and just find out what is the minimum frequency. So if frequency of I is less than minimum frequency, min frequency equal to frequency of I. And whenever we find a minimum frequency, we also store the number, min number equal to I. So once we have the minimum number and the minimum frequency, we can get the answer by doing min number plus value into min frequency. Okay, return. What is this? Mod equal to num percentage value. Yeah, let me submit. It works. Finally, let's do the time and space complexity analysis. So for the time complexity, first we are iterating on the number array. So this is order of n. And then we are iterating on the value. So we can see the both number and values are in the range 10 power 5. So you can say the time complexity is order of n plus value. And for space complexity, we are creating a frequency array of size value. So space complexity will be order of value. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. And let's catch up in the next video.